Synthetic division. After doing the quiz and reviewing, this should be pretty simple, easy. What goes in the box? Nobody's here. Anybody? What goes in the box? 2. It's 2, not 2. 3, 7, negative 20. How does it go? What's that iteration? How does it go? Anybody? En español está bien. Bring down the 3. Then what do we do? Multiply the number in the box times the number that's under the line, which is 2 times 3 is 6. Then we add. Then we go 7 plus 6 is 13. Then we multiply 2 times 13 is 26. And we add down in the there's a number here at the end. It didn't turn out to be 0. It has a remainder. So this is the remainder. All right, so let's go back to elementary school again. And what does it mean when we say that a number is a factor of a number? Another number, it's a back in elementary school. So we ask, yeah, is it a factor? How do we know if, like, say the question is 3 a factor of 12? Let's go like that. Very simple question from middle school, elementary school. Is 3 a factor of 12?
Yes.
How do you know it's a factor of 12? Why? I'm deaf. Can we, when we want to talk, can people talk a little?
Because 3 times 4 equals 12.
But more to it, like more.
12 divided by 3. Tell it how you.
How about there's no remainder? See, maybe that also. It divides evenly, exactly. Like if I say 3 goes into 12, 3 goes into 12, 3 times 4 is 12, and we minus, and there's no remainder, pretty much. So if I would have asked, is 3 a factor of 5? Is 3 a factor of 5? And why is it a no? It doesn't divide evenly into, or basically the remainder is not 0. For what I'm trying to get to here today, is that if you divide 3 into 5, 3, so it goes 1 time, 3 times 1 is 3 times 1 is 3, and then you subtract, and then you're gonna get a remainder that is not 0. See right here, when you did this, 3 times 4 is 12, and then you get a remainder of 0. So you need to get a remainder of 0. If you have a remainder of 0, then it is a factor. That's what we need to know. So right here, there was a remainder that is not 0. Then it has a remainder. This is not a factor. Not a factor of that polynomial. All right. So for what we're going to do today is called the remainder theorem. Lesson 4F, the remainder theorem. And here's the theorem. If a polynomial f of x is divided by x minus a, then the remainder is r equals f of a. Okay, so this is, I guess this is somewhat what I was talking about. Okay, so let's do a problem based off of this statement. Determine if the given binomial is a factor of the polynomial function. All right. Now, is this the problem from the warm-up? Yes. Yes, it is. All right. So what we're going to do is we're just going to work out this statement. If a polynomial f of x is divided by x minus a, then the remainder is r equals f of a. So here, r is equal to f of a. This is the remainder. And the remainder is f of a. Where it comes from x minus a. So I need to evaluate f of a. But what is a? Anybody, what is a? I actually have to work it out. What is a? See, x is this x, and minus is this minus. So what must be a? What must be a? What must be a? A is 2. I can't make it any simpler to understand about what is a. X is this x, minus is this minus. So a better be equal to that 2, which is the other way I was looking at before. It's 2. What makes the quantity 0? Another way of looking at it is x is going to be 2 minus 2 is 0. So, but anyways, it's 2. All right. So let's go ahead and work out f of 2. So we're going to plug in x is 2 into this. 3. X is 2 squared plus 7. X is 2. X is 2 minus 20. Yeah, this is all now elementary school math. Anyway, 2 squared, this is 2 squared is 4. 4 times 3 is 12. 7 times 2 is 14. Minus 20. 12 plus 14 is what? 12 plus 14 is? And what's 26 minus 20? What was the remainder when we did synthetic division in the warm-up? So there's 2 ways of doing it. F of 2 is 6. Now, because I got something that is not 0, therefore, x minus 2 is not a factor of this polynomial. And that's the lesson for today. That's it. The given binomial, this is a binomial, the given binomial is not a factor of this polynomial because there was a remainder that is not 0. There was actually some other number not 0, so it's not a factor. That's it. If it would have turned out that it would have worked out f of 2 equals 0, then what can we say if it would have turned out to be 0? The given binomial is a factor of polynomial because the remainder is 0. That's the idea. All right. So that is it for today.